thumbs up. Thank you very much. So just a brief overview, as Montana mentioned, we're going to have a couple speaking sessions today. It's basically an opening for what's going to happen tomorrow and having conversation and taking our time with utilizing some software, some data, and maybe seeing how spatial technologies, specifically GIS, might be beneficial to everyone around the table. So, Ani Bonjour. My name is Alice Gergachuk-Mannion, and I am a faculty member and the Geospatial Learning Specialist here at the School of the Environment and also at the Great Lakes Institute for Environmental Research at the University of Windsor. Today, I'm going to be focusing on specifically more or less what spatial technologies are, but with the main focus on GIS. I will do it more as an overview, where Corey and Cassie will talk about it in a little bit more specificity, specifically focusing on Indigenous services and what can be utilized within our communities. I also want to state a land acknowledgement, specifically for the Windsor-Essex Peninsula, the fact that the university does sit on the traditional territory of the Three Fires Confederacy of the First Nations. This is including the Ojibwa, the Odawa, and the Potawatomi. And we also look at this, and as Clint said, we also want to acknowledge with gratitude everything from the air, the water, fire, and every being of creation that we support and that they sustain us. We also honor the long-standing relations of the First Peoples to this place in particular from time immemorial. This also includes the Anishinaabe, the Haudenosaunee, the Lenape, the Huron, and Wendat peoples as well. We acknowledge also colonial harms, and we commit to renewed and respectful relations to our people, to the nature, and to this place. So usually when I start talking about things like spatial technologies or GIS, I actually start talking about it from the concept of our home and where we live, our beautiful planet, Turtle Island, and anything that we do in our home environments. It means that we're doing something in a place, in a location, that everything happens somewhere. And knowing where something happens usually is what's critically important to actually coming up with decision making. We also utilize our beautiful home for traveling purposes. We live off of it and from it. We extract from our home and we impact our home. And in return, our home does impact us. We see things and these changes happening from climate change, disease, etc. But in the end, all these interactions, these processes that happen, natural or that are actually human-induced, it is reliant on this concept about location and knowing about that location and knowing about the relationship we have with our geographies, with our nature, and trying to visualize this, especially those interactions and those stories that we have. So it always starts the fact that this is what we do every day. And how do we actually tell these stories? So again, I live here, so I'm surrounded by things like water. I'm surrounded by nature. I'm also surrounded by urbanality and a lot of other things. And so I look at everything from a very mapped perspective, and how we actually portray those relationships. But in the very beginning, we also know that we've been leaving our marks in many different ways. And again, we are mapping our stories, we're mapping our lives, we're mapping these relationships. This is actually what's considered one of the world's oldest maps. This was actually found in Spain, and there are others. But what's interesting here is that we're looking at how things are depicted in terms of their relationships, where the homes are, where they actually have bridges or passing, ibex, which is following the different herds, the migration patterns, whether there's rivers, the meanderings of those pathways in those rivers. And again, we're constantly doing this. We're also utilizing very different materials. In the background, you can see here we utilize paper, but in fact, we also know that many different societies are looking at it from the perspective of using natural-based materials. The Kalalit Nuat people in Greenland actually use portable maps where they use driftwood to actually utilize and navigate through these different landscapes and their windy coastal waters. We also share our ways, meaning our ideas, our knowledge bases. And what we've started to see is that from an Indigenous perspective, things like song, story, language, ceremony, sacred sites, navigation, migration, movement, relationship to nature are some of the things that actually are being passed down to set up what was now called Decolonize the Map movement. And what's amazing about this is that it's basically a growing effort with Indigenous communities and scholars to challenge colonial perspective and how traditional mapping is done. And it's actually re-engaging and recentering indigenous knowledge as the primary foundation for this, changing the place names and also changing spatial understanding. This movement also helps to look at the preservation of cultural heritage, youth education, and generational transfer knowledge, connecting the physical with the sacred, supporting Indigenous land rights, and environmental stewardship and sustainability of those lands and beyond. And at the forefront, in partnership with traditional knowledge, the mapping movement also starting to rely on some of these modern technologies, the geospatial technologies as they're called, the trifecta. And this consists of geographic information systems, global positioning systems, and remote sensing. So one is a computer-based system that actually allows us to store and change data, visualize it, interpret it in multiple ways. GPS systems actually allow us to record where we are on the Earth's surface to give a foundation of location to some extent. And obviously, remote sensing is not being on the ground at all, where something is utilized like a satellite with large cameras and sensor technologies that take images of our beautiful planet and collect all different parts of the world and the data that's collected in those imagery-based files. But I'm going to be focusing a lot more on geographic information systems, as this is what we're going to be working with and playing with a lot tomorrow in the lab. I will talk a little bit about misconceptions about GIS. Some people have these ideas of what GIS is. When we talk about geographic problems, what they revolve around, what the overall definitions are, the fact that spatial data is important to a GIS system, different applications of GIS from a very broad perspective, and maybe some Indigenous mapping resources to consider, looking at different software, mapping portals, and data hubs potentially. So first thing that we get that I hear a lot of is, isn't GIS similar to a CAD-based system and computer-aided design software? And usually CAD-based systems are used for developing drawings, plans, but they do not have spatial analysis capabilities. And they might have a database management as part of it, but it's not in the same context of how a GIS is utilizing their databases for querying, asking questions on the map and within the table format. I also hear that GIS, it's very good just for making maps. Yes, this is true. However, GIS's power really resides in the fact of the different procedures that it actually allows us to utilize, the overlaying of layers, examining relationships between features, themes, maybe utilizing some geostatistics, looking at densities, interpolation. So again, trying to build contour mapping, elevation mapping, trying to find out where the hotspots of specific species are showing up. Also, modeling is part of GIS's framework. Maybe I want to model how a river flows, how something in the river can be tracked by that flow, the movement of pollution, or maybe species invasions or changes over time. And also taking into account projections and coordinates, meaning how do I locate myself actually on the surface within this map context. So while GIS, the foundation is all of these things, and it's great to have the maps at the end as the product, but it's so much more than that. So just to give you an example, a CAD-based system, here's actually a floor plan, let's just say, of office spaces and cubicles, but there's no real interactions beyond this point. However, if we're looking at a GIS system, what we can start to see is the mapping framework itself, every point representing, let's say, a sample of, let's say, looking at nitrogen dioxide or a pollution sample. And every sample is tied back to a location within a database. You can symbolize this, you have tools to ask different questions, etc. It's a very unique software that does some amazing things. And mainly, when we're working within a GIS framework, we start to think about geography. And a lot of the problems revolve around things like scale. How detailed do we want to show our maps to be? What do they need to show at what capacities? Or are we looking at more broader or regional scale problems or initiatives or solutions? It's also about tackling a purpose. What's the basis of intent? So, for example, do you have a question? Where did my ancestors come from? Or maybe where are the highest levels of eutrophication in Lake Erie, and who does it affect? So maybe we start looking at language patterns, surname concentrations, or dispersion patterns with population patterns. And again, time is one of those as well, where we can actually look how time changes and impacts things like lake levels, deforestation, changing of habitats and environments through that temporal range. So when we think about scale, I always look at it from the perspective of the detail aspect versus the more regional aspect. So for any of you that were familiar with what was going on with the Fukushima nuclear disaster in Japan, so it's in 2011, this is actually looking at a regional map that highlights different areas of Japan, but looking at how actually nucleides basically that they're tracking are traveling from the source all the way within the water system in the ocean. And again, what this does, it starts to show impact beyond just a country, so to speak. And again, it's going into the natural areas. They were finding radioactive isotopes all the way in shark species that formed up all the way in California. So again, to be able to map these sorts of things out and to track these things goes beyond just our locations in our homes and where we affect beyond that. So this is showing something more on a regional or global scale. While we're looking at something more on the localized scale down here, where we're using orthophotography or high resolution remote sensing satellite images to actually look at the reactor itself in its detail. And again, not being on the ground, being able to do this in a safe distance, but be able to monitor as much as you can from this unfortunate disaster. But again, different ways that spatial technologies can actually help us to track these things at these different scales. Or maybe looking at ancestry from a language perspective. So this is Native Land Digital, And again, they have a lot of these different delineations and boundaries, not how we view things where they're provinces and territories, but we're viewing this from a very different perspective. Maybe we're interested in treaties and where treaties actually affect different nations, the languages itself and what those boundaries look like, the territories. And again, the map looks so much more different than if we look at a general map of Ontario. Ontario would look very different if we actually looked at it from a native territory perspective overall. This is a really great resource. I actually have a link to this. It's an online mapping resource that you can take a look at and work with. And it has a lot of wonderful information. And again, decolonizing that map, this map movement that we're starting to see a lot of Indigenous knowledge come through. And again, when we're looking at things like time, if I'm looking at remotely sensed images and looking at frequency of cyanobacteria, or in our case, algal blooms, these things actually start to affect populations, animals, and can we look at this over a time scale analysis? So in our case, what we can start to see is Lake Erie. We start to see part of Essex County down here. And over time, how quickly does algal blooms actually grow? So by using these different technologies, we can actually track these things as well. So we always start with that concept of what is geography, and really then how do we study it? And as GIS started to come out as a technology, some people always ask me, what does it mean, a GIS? So people tend to break this down into three different terms: geographic, meaning actual location; information, which is the actual data, whether it be quantitative or qualitative, about those features. And this can actually include everything from measurements, coordinates, place names, and the systems themselves. Working with a computer, working with a network-based system, an internet, a cloud-based environment, how to store data in a database. It's amazing what people can learn when they think they're just going to be studying geography, but what they can learn is that they're actually looking at information in a very different way and storing it in systems that sometimes they might not be comfortable with. I have that with students all the time where they come in and say, Miss, I'm not very technically savvy. And that's okay. The thing is, what GIS does is it helps you learn these things as you go along. There are also multiple definitions where they say GIS is just a hardware software package, and it's really just for capturing and analyzing data and maybe displaying it. Others view GIS where they start to look at the understanding of a question to interpret and visualize that data, but they're interested in revealing relationships, patterns, trends, and that can be shown in a form of a map, a globe, report, charts, etc. It's a very creative process and a very visual process. I'm not sure if you know this, but GIS actually, it's not just a software package. It actually is its own discipline. There's academic theory behind the development and use of these systems themselves, and not just from a computer science perspective, programming and everything else, but the reality is that people are trying to figure out how to use geographic concept, distance measurement, um, looking at exploration or expansion or interpolation. And how do we actually build those concepts in the software so that everybody can use them? So it's really the science behind the technology as well. And it is a multidisciplinary field. It doesn't mean it's just computer science people. It is geographers, computer scientists, geodesists, cartographers, anybody interested in satellite, remote sensing, social sciences, ecology. They all come together, psychology, to actually make the system something that's useful for everybody. It allows a different sort of creative and freedom process on how they want to interpret their data. Some people define GIS by their job or the tools that they use primarily. Maybe they're focusing more on the database side, how they index and actually put in data within a database so that you can ask questions of that database. Maybe it's an organization that's dedicated to using GIS for the advancement of storage, retrieval, or displaying of geographic data. It also could be a programmer who loves to do programming within a GIS. There's so much flexibility, and different people use this all the time. Some might want to use it for a main decision-making capability, so they focus their GIS to be specific on one theme. Maybe it's health, forestry, land use, environmental, or maybe just a cataloging of their data overall, a repository. A good example here is actually trying to track wetland inventory progress. This is Ducks Unlimited portal where they're actually tracking the different types of wetland inventories and how far along they've gone in that process overall. So this actually helps them make decisions on where they can focus their efforts more, and maybe where things are more completed, what further they can do to enhance and keep those wetlands healthy and happy. People also talk about GIS from the part of where it's a combination of understanding the hardware needed, the software that's needed to actually utilize the data, finding the data, organizing or creating your own data, the different techniques and tools that are available to you. But most importantly, it's the people. It's the person that becomes the creative explorer. Without you, there is no question. Without you, there is no capacity to ask further, what can we do? How do we manage these things? How can we make this better? And I think that's the most important aspect, is having people that are willing to learn these technologies to explore what it is that they want to actually interact with and talk about in terms of a relationship from that visual capacity. People also talk about GIS from three viewpoints, and we break this down: the software itself, where the map is the view. So a picture, they say, is worth 1,000 words. I'd say it's a lot more than that. But again, a good GIS system, whether it's an open source free system or something that you do pay for, they have one of the best mapping capabilities around. Great cartography, great way to visualize something. And what you can see here is that maybe that's about the symbology, visualizing where different vehicle accidents occur on these main roads and what type of collision it was, etc. Versus having the capability to creating a map and maybe utilizing things like a legend and a scale bar for distance capacities, etc. So again, the cartographic elements are part of GIS. The database view is very important, obviously, because it stores the actual spatial data in a repository for storage and management, and it allows you to select out and query data or information within that database and in the map framework. So again, what we see here is, let's say this is the city of Windsor. We're actually located right here. The University of Windsor is right here. Detroit River here. This is actually an air pollution model for nitrogen dioxide. And again, if I wanted to ask a question, to actually look at the road, Tecumseh Road, I've highlighted the road itself here. So we have the actual model showing nitrogen dioxide, but we also have, let's say, what is going on this road, where you can actually start to query out, find me all the lines that have the street name Tecumseh Road. And there, it actually gives you all that information about every line segment that makes up that road, and it tells you what the different vehicle counts could be on there. The idea is also, if I'm looking at a location and I want to find out what concentration levels there are, I can actually put a little dot on there and it'll tell me roughly what that model is telling in terms of nitrogen dioxide concentration. So the geodatabase is actually a very important component to a GIS. And there's obviously the model view, having analytical rules, tools that are available for you to do in a sequential manner, for you to process and take functionality to create a model. So for example, let's say we're looking at where we want to plant or actually plan out if a road needs to go in or some sort of utility pipeline needs to be built, maybe for internet or something else. And again, we also have environmental regulations that we want to comply with. So maybe that road or pipeline needs to be 500 meters away from specific endangered bird nests. So by just having different tools, something called the buffer tool or the intersect tool, we can actually answer that question by saying, let's put a 500-meter buffer around that road or that utility pipeline and see how it intersects with where some of these nesting sites are. And the question then becomes more of a decision-making capacity. Do we now build the line here or not? Are we willing to make that sacrifice? Again, but this idea that there's analytical capability through just modeling frameworks is really important within that GIS framework. So common tools that we're going to maybe see tomorrow are things like the buffer tool or the dissolve tool, the clip tool. So again, how to take data and then create a new form of data to do our analysis. Maybe we're going to intersect two different layers to get a new output and have a combination of those two layers. Maybe we're going to look at distance from one location to another and actually measure that out within that spatial capacity. GIS is also formulated on what type of data it uses. Spatial data, as long as you have some form of coordinates, whether they're latitude and longitude, or universal transverse Mercator, easting or northing, or none at all, you can obviously make your own coordinates, still map it out. But the idea is that it has to have a spatial factor. And then you combine with this with what's called aspatial data. This could be data that's relevant that explains that feature. So maybe this could be the age, the height, and its measurement that's not associated with geographic location. So it's a lot of merging of this information, which is great for data. And spatial data can also be shown in multiple ways, continuous and discrete. Continuous meaning that it's all in one landscape. It covers a large swath of land, meaning that there's no area that has no measurement. It's all measured. Versus something that's discrete, meaning individual features, fire hydrants, trees, and buildings, anything that occupies that Earth's surface. And when we talk about continuous data or discrete data, we basically look at discrete data as points, lines, or areas. And anything that's continuous is usually called a surface. So for example, you can show cities as points or towns as points, rivers as lines, and parks as polygons or areas. Meanwhile, a digital elevation model can highlight elevation on a continuous landscape overall. Spatial data layers stored in a GIS in layers, which we'll be utilizing tomorrow. I'm very excited. And they're stored as what's called vector-based data or raster-based data. Vector data are the points, the lines, or the areas, and rasters are basically image files, almost, that are made up of little cells, little pixels. So if you actually take a digital image and zoom right into it, you'll notice that every image is made up of little cells. So because we take satellite imagery of the Earth's surface, a lot of times that comes out in these raster formats. Another way to view it is, again, points, lines, and areas, parcels, transportation networks, maybe your house overall. And we can change that into a raster format. However, maybe not the most beautiful and precise. But again, depending on the format or the model type you're working with, these are the different formats that GIS take into consideration. We also know that in order to create data, most countries actually have standards that are followed. So if we're creating road data, if we're creating soil data, geology-based, hydrology, water-based data, there's a certain standard that everybody follows so that everything is consistent. So if we wanted to download a hydrology layer of all the hydrologic network, all the rivers and streams for all of Canada, we can do that. And they actually had everybody put together that framework. They basically followed that standard. So they had the same variables in the attribute table or in the database. They had the same way that things were actually delineated using a line-based format, etc. So again, knowing that there are standards out there, we actually have a lot of data that is utilized by different groups, but by following that standard, it stays consistent. And also, I'm the one that talks about this a lot to my students, but a good spatial person when they're creating data or layers, usually what happens after is that you should be writing what's called metadata. It's basically telling me more about that layer. It's the data about that data you just created. So who created it? When was it created? Why? How? How should it be used? What scale was it set at? The reason is the more information we provide to each other as spatial scientists, it helps us to determine whether that data set makes sense to use in the model, or is it going to affect the integrity of the model. This actually sets the integrity and applicability of your own data. And it's a way to actually monitor the investment that you put into data creation as well. So there are different standards that are utilized when creating metadata for your data layers. It's a tedious process, but a good spatial person does this. So metadata is very important, and it's a great way for us to select out and search out data layers from all over the place if good metadata is set in place. And GIS can help us determine things like and answer questions that are associated with location. Where's the nearest fire hydrant? Or a pattern? Where's the highest concentrations of, let's say, benzene? Or what's the flow of traffic look like? Maybe we're looking at crime-based analysis. Or trends, looking at health-based analysis. Where do we see that there's more populations, maybe of children that have asthma? Or if we're looking at that in combination with air pollution patterns, or if I'm looking at a wetland in distance away from leased oil properties, how do we start mitigating some of those factors and impacts if we don't want to have these leased properties anywhere near some of our natural sites? Or if we build something, a new building, how will it affect the residential neighborhoods and traffic flow? So GIS can actually help in a lot of capacities to do this. And GIS is actually used by so many people, even everyday people. We get in our vehicles, and if we have a navigation system, that's basically GPS with GIS, and you're using it every day. On your phone, we're using it every day. So the idea is, how do different people utilize GIS? So everything from different disciplines, professions, organizations, and different purposes. Looking at land management, watershed analysis, engineering design, logistics routing, incident mapping, etc. Maybe you're looking at the overall topology and elevation of your topography and elevation of your locations. And I'm not going to get into all of it because I think Cassie and Corey going to be able to do this much better. But I do have a little link that actually highlights all the different applications that GIS can help do. So I will be providing this presentation as a PDF with these links in them to everybody in the group. So just to give you an idea, again, when we're talking about applicability, maybe looking at invasive species. So this was a study that I worked on a while back on looking at probability of risk of lionfish coming onto different coastlines, especially North America, South America. And it's not a species that's actually native to the waters near these vicinities. So now we're starting to look at what destructive nature some of these fish have to the natural fish habitats within these locations. Or maybe we're looking at cultural aspects and looking at who lived where before colonial times, looking at it from an archaeological perspective, but also from a cultural perspective, and what sort of different materials and uses of different tools were being used, how they were being used pre-colonial times. This can help us this tells us a lot about our different cultures and how we actually um, did things in the past, and then what can actually come forward for future discussion as well. Maybe we're looking at using GIS from a prediction analysis, what happens to different precipitation changes when we're looking at 1976 to 2005, what happens if we project precipitation change due to climate change scenarios 50 years from now? What would that look like? What areas would be impacted? Notice the Arctic is really standing out quite a bit in some aspects of the prairies. Maybe we want to look at hotspots where things are actually occurring the most. Why? Why those specific locations? So maybe you could look at something like traffic accidents. Or from a business perspective, where do we actually go? Thinking of Tim Hortons, how many Tim Hortons do we have all over the place? Imagine mapping all that out. Or different services, maybe looking at midwife services that certain areas would need those services because there's not hospitals in play. But again, different ways that GIS can be used to map those capacities out. Looking at everything from a three-dimensional analysis is fantastic within a GIS environment. Looking at it from an urban planning perspective, flooding, looking at it from, actually determining where we're going to start to put different natural resources or mitigation factors, but looking at your landscape in this different visual context is very helpful as well. Figuring out how water flows and if we actually have pollutants in the water. Start somewhere, and then does it move? How does it move? Where is it going to move? Where is it going to end up congregating at the end? So again, looking at things like modeling those perspectives in GIS is possible. And again, looking at different aspects of your neighborhoods. This was just working on benzene, looking at gas station emittance. And again, how does this affect neighborhoods over time from a health-based perspective? So if I had asthma patient information on here, and then it could target maybe different neighborhoods to maybe say, could we kind of mitigate what's coming out of some of these areas? Or maybe we're looking at our neighborhoods and understanding poverty levels and why does poverty exist? Where does it occur? And how do we mitigate those factors as well using GIS portals? So a lot of times we could put this data together to show where poverty might exist, especially within the Windsor-Essex region, especially those dealing with children. And then how do we start to change that conversation to help and see if we can alleviate some of these issues. And again, one of my favorite maps, I love showing this map. This is the one where you take North America, but imagine this, looking at the map of Turtle Island in a different capacity based on just the overall communities, the native communities that are out there. This isn't about provinces and territories. Look at how different this map looks. And it tells us about all these different groups that have all their different cultures, different languages, and that we share this beautiful place. And there needs to be a lot more conversation about this. So again, the Native Land Digital, if you ever have a chance, take a look. It's an amazing portal that shows a lot of different information. Again, a GIS overall. I also wanted to talk briefly about, and I'm going to be done fairly soon, so I apologize if I'm taking a little bit of time. I want to make sure that people are aware that there are different things that you can look at in terms of software packages. ESRI Canada actually is a proprietary software company that makes one of the biggest GIS products in the world. However, they do have a foundation where you can see, and I'm just making sure, Montana, can you still see the screen? Okay. So also what they have here is looking at the different ways that Indigenous peoples are utilizing their software from a story map perspective, land management perspective, mining, and actually strengthening Indigenous communities by using GIS and their software. They also have licensing that's dedicated to Indigenous communities that actually have maybe a reduced value in terms of what the cost is. But the fact that the largest GIS software company in the world, where a lot of the jobs are actually utilizing the software, they have these capacities. So if you have that capacity where you can maybe get this type of software, I would strongly recommend reaching out to them just to see what's available. But know that there are a lot of Indigenous communities that are starting to utilize these softwares. One of my favorites is QGIS. Let's say some areas maybe don't have the financial means. And again, we utilize this. There is free GIS software that is a full-blown GIS that you can download, which is called QGIS. It was created by a high school teacher, actually. And it can be utilized on Mac-based systems as well as PCs. So if you're just willing to just download and try, they also have tutorials, they have different resources that you can look at, but it's a great way to try to take on a GIS and where you don't spend a lot of money and try to use it to see if it's going to be useful for whatever it is that you want to do within the territory or for yourselves overall. There's also something called the Indigenous Mapping Collective, if you haven't heard of this. This is the group of individuals across the nation that have come together that actually share their knowledge about the tools and the training that they actually have used to map their lands, how to share their stories, and how to decolonize the place as well as the space. I am part of this. I actually am a member of the Indigenous Mapping Collective. They hold overall multiple different workshops, conferences. So for anyone that's really interested in utilizing spatial technologies for Indigenous knowledge, this is a great opportunity to join and become a member. You'll have access to a lot of different webinars that they have that tie back to different stories. It's an amazing, amazing resource. The native digital land, which is the one that I have shown you, again, we'll show you again, which I love this. I do show this to my students quite a bit. And again, it's looking at not just Turtle Island, but obviously all over the place in looking at Indigenous communities and how they're actually perceiving and putting their mapping information in there as well. It's tied to the territories, their languages, and also treaties and land rights as well. And just so you know, I wanted to also share this. Carleton actually has a wonderful Indigenous resource of different GIS data that you can utilize, online maps as well, different atlases, ethnographic mapping labs, First Nations in BC, Western Canada, looking at maps of treaty making, Pan-Inuit trails, and again, the list goes on and on. And what's amazing is how much the Indigenous communities have really taken to these technologies to make their stories known, to make their knowledge known. and it's amazing. So all of this will be shared with all of you once I'm going to put the presentation together for you as a PDF. So on that note, that's just telling you what GIS is, a very overarching view. The fact that you're going to do some of this in the lab tomorrow, we'll talk about some of these terminologies and have a little bit of fun. But I do want to say thank you to everybody that helped out putting this workshop together. And especially to our participants from far and wide who are with us today and who are hopefully going to be with us tomorrow. We appreciate you very much, and just know that this was really exciting even for myself, but I hope that this gave you some indication of where we're going to go tomorrow a bit. So Chi-miigwech, if there are any questions, I'll take some. Otherwise, we'll pass this on to our next speakers. Thank you.
I think we were going to take a quick bio break before our
Sorry,
next
that's right.
speakers. So if there's no questions, we can take that. I'm wondering if we should shorten it to 5 minutes instead of the 10, if that's all right with everyone. I see some head nods and some thumbs ups. Okay. So I guess it just changed time now. So we'll take a quick break and hop back on at 11:01.
Thank you.
Can I just see some thumbs up from participants to see if you're back at your computer? Okay. It looks like people are starting to hop back on. Yeah, so I guess we'll start the next session. So we have Corey and Cassie. I'll let them introduce themselves, so you guys can feel free to take it away.
Sounds good, Miigwech, Montana. I'll just share my screen here, make sure everything's good. Everyone see that okay? Thumbs up. Okay, I'll put it in presentation mode here. And I won't be able to see if there's any hands up, so just feel free to scream at me at any time if you have any questions. But yeah, thanks to Alice for connecting with us and having myself and Cassie speak today and kind of share some of our career experience as well as our passion, as well as some of our lived experience and how this pertains to GIS and some of the applications for our communities and how we can bring that back. So let's forward here to the next slide. So as I mentioned, Corey Kinsella, I'm from Curve Lake First Nation, just north of Peterborough. I have a background in earth sciences or geology from Fleming College, and I've spent a lot of my career either in the natural resources sector and mining, as well as consultation for my community here in Curve Lake. And now I'm a project lead for CIPS, Cambium Indigenous Professional Services here located in Curve Lake. And I look after physical sciences as well as traditional lands. Let Cass introduce herself.
Hi, everyone. My name is Cassie McEwen. I'm from Alderville First Nation, and I work at CIPS as a project lead for lands and land relationships. So I get to do a lot of really cool work in community with environmental NGOs, government, and kind of like foster relationships between all of the different, I guess, like different sectors and things like that. So I'll be talking today a lot about land relationship visioning and the GIS applications through land relationship visioning. So thanks, everyone.
Thanks, Cass. And then, yeah, as for CIPS, we were formed in 2014, and we're a team of now 18 all First Nations people that have specializations in a whole bunch of different fields, and we combine kind of our Western science academics with our traditional knowledge and values to the betterment of our Canadians, our Indigenous communities across Canada. So we provide advisory consulting, so help with a lot of capacity with communities that a lot of our communities don't have the resources to react to certain projects and different things. So we help out a lot with our communities and target our services to make sure that our outcomes for our First Nations is first and foremost. So that's SIPs, and then I've got an agenda here. So I'm going to touch on kind of the GIS applications in a broad sense and in a different number of terms here, and then Cassie's gonna at the end here really bring it home with the work that she does with land relationship visioning and apply some of those themes and applications and how it can be used within our communities. So first, yeah, going to touch on lands and resource management, right? As stewards of lands and the waters, it's of the utmost importance for us to protect and enhance our resources in around our communities as well as our traditional areas. So how can GIS help us? There's a real potential to integrate all of these applications and technologies into our land management, and it offers strategies for our communities, and it can be a really valuable tool for, like I said, preserving and protecting our lands and our resources. And breaking it down here a little bit more, we can focus on our traditional territories, our land claims and land use that Cass is going to touch on later. Ensuring that our boundaries are respected. We're preventing encroachment, unauthorized development, and resource extraction. So in some of our territories, a lot of resource activities is going on within our treaty territory here up in Treaty 20. There's a rich abundance of limestone that's pretty sought after. So just being able to map where these activities are going on, where they're proposed to go on, helps our communities to make informed decisions about our rights and protecting our rights. And mainly our consultation departments are able to lean on these types of maps and tools to validate some of our claims about what we're seeing. And then a step further, I do a lot of harvesting and exercise my treaty rights here in our treaty areas. So, wildlife and harvesting areas is something that's important to me. And I use GIS and different apps, even on my phone, kind of on a daily basis when I'm in the hunting and fishing seasons. I'm able to, monitor where I'm seeing, deer or turkey or moose and where they're frequenting. It offers tools and layers within these GIS softwares of, just understanding the contours of the land and how that can funnel kind of wildlife activity. Even the tree species, right? If you toggle on some different layers and some different historical overlays and mapping, well, you can, I like to use the fall kind of overlay, and you can see the different colors of the foliage, and it helps me understand, okay, maybe there's a big stand of oak trees here that's producing acorns that can kind of bring in some deer activity. So it helps me out there when I'm on the land. And then even you think of when we're out there fishing and you find some good fishing spots that you want to keep to yourself. Well, there's some pretty good apps out there that utilize GIS software where you can, make your pins on a map where you can return another day and hopefully have some more success. So it's there's a variety of tools and apps out there that we can use, but on a community level, it also allows us to monitor our population's health in terms of wildlife. And we can monitor their movement as well over areas over time. And it gives us a lot of insight as to what's going on year over year, season over season. And even if these activities that are human-centered might be impacting them, like I said, could be proposed mining activities, forestry, but it allows us to kind of validate some of the on the land knowledge and information we're picking up. And then obviously of significant importance to us in thinking about consultation departments, as well as, you know, monitoring our cultural sites that have been sacred to us for, you know, for generations. You think of kind of our camping areas along portage routes, or archaeological sites that, you know, our elders have told us about orally, where they exist, and how we can validate that we know they're there. And in the case of, you know, someone wants to build a subdivision kind of on the lakefront, and we know that there's potential for our resources and our artifacts to be impacted. So GIS helps us strengthen our validation and our information for that, to protect for our future generations. So yeah, moving on into kind of forest health and sustainable resource management. You know, we can capture some really detailed images and data on forest conditions, and then we can allow ourselves to take steps to manage these resources and really stand up for our rights and ensure that, like I said, future generations can continue to maintain this balance on our lands and our forests over years to come. Again, significant importance is water source and the protection that we have Indigenous peoples to make sure our waters are protected and clean for 7 generations. You know, GIS and even drones, you know, these drones are getting so sophisticated and have so many tools that we can use with drones to monitor, you know, rivers and lakes and reservoirs. It even allows us to detect signs of contamination and, you know, what these flow rates are, how the water is moving, just so we can, again, if we have to make a claim about contamination that we're seeing as communities, then we can use these tools and these technologies to strengthen our cases here. And then kind of in the contemporary space, you think of agriculture. You know, we do a lot of agriculture. I'm sure a lot of communities to the south as well have agriculture going on. So, you know, it can only strengthen our tools, our toolboxes, and help monitor our crops and monitor their health and how our yield is going. And it also helps us support sustainable agriculture practices for our food security and sovereignty, as well as economics, right? That's important for us. Yeah, getting a little bit more in depth here. When you think about environmental monitoring and climate change adaptation, you know, it's a big focus here at SIPS, and how we help communities is monitoring what's going on in the environment, as well as climate change adaptation, because, you know, we're typically impacted by climate change at a disproportionate rate, as you know, we're typically located near water bodies. We rely on our traditional food sources. We want to eat the foods that we know are healthy, that come from the land. So, you know, these tools, like I said, whether it's drones, it's GPS coordinates, you know, you find something in the field that is informative or intriguing or concerning, you know, you can pinpoint these locations on a map, and then from that, you know, kind of extrapolate using GIS to monitor these conditions, whether it's populations, deforestation, like I said, water quality, and climate change impacts, right? You think of invasive species, you know, they love these warming climates, and, you know, we see a lot of intrusive activity from invasive species. So really helps us monitor and validate and store a lot of this data that we're out there seeing. And, you know, a lot of it can be done in an intrusive manner. This picture I have on this slide is from a fish spawning survey that we did for a community here, Georgina Island. And, you know, we were able to locate some northern pike that the community hasn't been seeing in the last few years, and we were able to identify them using a drone. They were, doing their thing in the spring, getting set up for spawning, and we weren't crashing around in the water, kind of disturbing their natural activity. So really cool, neat ways to get some high resolution validation about what we're seeing when we're doing monitoring in the environment. Yeah, and then bringing it to, our cultural and our traditional knowledge, and how can we map that? A lot of our stories and information has been passed down orally from generation to generation for a number of different reasons, right? The scarcity to get this information out into the non-Indigenous hands, and how we've been burned in the past. So you can understand why it's commonly not been recorded. And as well, it's how we shared information, and we still do to this day. I know I talk to some of the people in my community about how the fishing's going, and you get those apprehensive answers. No one wants to tell you how good they're doing or where they're fishing, and for good reason. But a lot of our communities are starting to really take advantage of this technology, so we can map and compile all these stories, all these traditional, it could be hunting camps, traditional territories, and that can be used in a variety of different ways. If it's just protecting or enhancing, or if we're seeing impacts coming down the road, then it gives us that validation again to really put our feet down and draw a line. So, and this image up above is again a Georgina Island First Nation. We did a kind of a cultural ecology knowledge study that was done with the community. So we've got a bunch of different things mapped out here, just really simply using Google Earth, right? We didn't use Esri or ArcGIS, anything that you had to pay for. I mean, Google Earth is free, and the community wanted to use it. So we went out and we kind of mapped some deer travel routes, as well as some spruce plantations, as well as some cedar forests. What else do we got here? We've got ostrich ferns or fiddleheads that the community, harvests and forages for. So, important species that our communities value can be mapped using GIS. And then, yeah, a big one, right? With a changing climate that we're seeing over, especially the last decade, seeing and hearing of a lot of these frequent 100-year events, right? So, GIS allows us to kind of look at where we're at, like Alice was mentioning, on the Earth, where we're at, and understand what the potential is for emergencies and disasters, and could be floods, could be wildfires that we're seeing quite prevalently out to the west. Flooding's a big one, especially for my community located right on the Trent Severn. We're at the mercy of Parks Canada and how they manage those waterways. And sometimes it raises an eyebrows with what we see in the spring or the winter and how low the water can get. So, it's about thinking about the potential for what can happen, and how we can prepare for these more frequent events, like I said, that are occurring to us. And then, yeah, a big one that I know me and Cassie are real proponents of is, our Indigenous-led conservation, and protecting areas that we know are important to our communities and have significance, and how we can use GIS to benefit these efforts. Using these tools and having a good grasp of them just only empowers us more to be leaders in this space. We know where these biodiverse rich areas are, and these tools, if you got a handheld Garmin GPS, you can go and do walkabouts, bio blitzes, take pins on your locations and take them back, and be able to map them in a real sophisticated way that, sometimes we do have to validate it to the Western side for them to accept it. But these tools are there that we can use, and it only strengthens our cases, or our claims in some cases. This picture up above, I'll just give you a little bit of background. So it's located on Pigeon Lake within the Kawarthas up here. So, it's one of the largest undeveloped islands in the Kawarthas that, as Curve Lake has histories, oral histories that, we used to camp and camp and stop along our portage routes when we were traveling and our nomadic ways back in the day. So, we partnered with Kawartha Land Trust to be able to protect this significant island to ensure that it wasn't going to be developed. It's not going to be a subdivision down the road, and we can take comfort that we had a partnership that took this seriously, and we were able to see that this area was protected and all these species can continue to thrive for years to come. So just one example there. And then, yeah, in the day-to-day basis, you think about within our communities, there's obviously planning and infrastructure development that comes with our rising populations. A lot of our community members want to return home for different reasons, to be, close to family, close to culture and language. And, with that becomes a demand for services, right? Whether it's social or health services, we have to get these in place so we can offer these to our people. So, GIS is there and it's available that we can, in a sustainable manner, and I don't want to steal Cassie's thunder for what's upcoming, but, we can really think about, what's the common sense, the real right way to build our communities for the future so we don't impact our important species or our significant areas. So GIS is there. This is, a lot of our counties that our communities are within. So this is a snapshot taken from Canada Lands, but, there's Peterborough County GIS. I know different counties have their own GISs where you can pull up your community. You can see all these parcels. You can understand what's banned land, what's certificate of possession land. But these tools are there and you can toggle off these layers and turn some different ones on to give you more information about what's there and what's going on. So can't say enough about GIS. I use it quite a bit in my day-to-day basis. Like I said, if I'm hunting or harvesting, or if I'm helping communities with different projects, these tools are there for us to just keep strengthening our efforts. So with that, I will turn it over to Cassie to her portion, and I'll let her take it away here.
Great, thanks, Corey. So hi everyone. I'm going to talk a little bit about, well, a lot about land relationship visioning and the program, the tool, the process, and how that applies to, or how rather GIS applies to land relationship visioning, and some examples that I've seen it being used in community. And so just to start off, land relationship visioning is a community-led approach to land use planning. And so what it does is it kind of takes that language of using the land out of land use planning, and we talk more about envisioning a relationship to the land. So that includes the past, present, and the future. It reflects a more holistic approach that includes community identified needs and priorities that extend beyond Western land use planning practices. So next slide, Corey. So just to provide a little more of an in-depth understanding of land relationship visioning, land relationship visioning is really heavy on understanding our responsibilities to the land and to each other. It speaks to kinship and community, cultural identity, traditional knowledge, and future generations. Land use planning, as we know, it's more of a Western kind of idea and process that talks or speaks a lot about, resource management and extraction. It's more hierarchical. It speaks to growth management. It's more data driven. We see a lot more discussion around infrastructure and regulations and things like that. And so land relationship visioning and land use planning, they meet in the middle. So they both are looking at a long-term vision for the land or for a community. It's all about community well-being. It's about protecting what's important. Increasingly, it's about climate change adaptation. It's about community engagement and buy-in. And then, of course, there are a lot of mapping components that are necessary to visually see what we're talking about. So overall, LRV, land relationship visioning, which I will refer to as LRV, can be a component of land use planning or community planning, but it kind of like widens that lens and is envisioning and planning for the future, however that is identified by community. And so it is a toolkit. So it's an actual like physical, well, it's a digital self-guided resource for First Nation land practitioners. It comes in the form of like a PowerPoint presentation. Right now we're working on a revamp. So there was originally 5 modules. We're adding 3. So now there's 8 modules that walk you through understanding land relationship visioning and then practical ways to actually implement that visioning process within community. Next. And so I'm going to talk about the core components of the actual toolkit. And this toolkit is available online. If you just like Google land relationship visioning, it'll take you to our website or the Ontario Aboriginal Lands Association website. Like I said, we're in the middle of updating and relaunching the toolkit. So there will be a new, fresh, updated toolkit out by the end of March. But for today's purposes, I'm going to talk about the toolkit and the process, and then how I've seen it actually roll out in community. And so as part of the toolkit, there are 4 distinct kind of components of the toolkit. We have a slide deck, which is a PowerPoint presentation. It's narrated and it's fully editable for community use, right? So it's supposed to be the communities to use as they see fit. Within each module, so there's 8 modules in the new toolkit. Within each module, there is an accompanying tool. So these tools look like Microsoft PowerPoint templates, Excel templates, and Word templates for documentation and planning initiatives. So we're looking at integrating climate change adaptation planning, invasive species management planning, and other different templates to kind of help guide a community in their land relationship vision. As well as in each module, there are engagement ideas. So land relationship visioning is very heavy on community engagement. The sole intention, I think, as I was developing the toolkit, it was really around things that I want to see in my community, which is definitely an increase in community education and awareness in land relationship visioning and our responsibilities to land. So within each module, there's engagement ideas. And we will see further on how GIS has actually been incorporated for within those community engagements. And then as well as throughout the toolkit, throughout the slide deck, there are a lot of external resources. So links and other different support for different LRV initiatives.
So
And so land relationship visioning, it's also a process, right? It's not just a toolkit, it's also an actual process that we've seen in community now. And the core components of this process would be identifying and documenting community identified significant species. So this is determined through community engagement, and it is very specific to community. So a lot of the times when we're speaking around Western land use planning and documenting significant species, there's a heavy focus on like legislated species, right? Species at risk, migratory birds, fish and things like that, which are all very important. But this kind of takes a bit of a step back and really gives that power to the community to identify what is significant to them, and then to actually document that and be able to make informed decisions around those identified species. The same thing with significant spaces. A lot of the times there's a really heavy focus on critical habitat and different legislated significant spaces as identified through legislation. Again, this brings the power back to the community in identifying those spaces that are determined through community engagement as important to the community. And I will talk a little bit about this later on. We did this process in community through programming with the Ontario Aboriginal Lands Association. And what was identified as the significant spaces in community was so different across the board. And so it's been really interesting to see how that interpretation of significant spaces has been used in community planning. Also, as part of the new updated land relationship visioning toolkit and process is the management of invasive species. So the identification and management of invasive species to understand best management practices. So we'll actually be including in the tool an invasive species management plan template. We've also included climate change to enhance community understanding of climate change impacts, to inform adaptation and mitigation, and looking at how climate change will impact land and land use, and all of this to make informed decision making using understandings of community identified needs and priorities. And so mapping in land relationship visioning, we do have a module that is dedicated to mapping in land relationship visioning. So mapping in a broader sense. And we walk through very accessible and simple methods to complex methods of mapping. So we speak about hands-on mapping. So that's like the most simple way to map, right? It's a way to communicate effectively. It's very accessible. Essentially, community members draw maps from memory, and these maps represent key community identified features on the land from a bird's eye kind of view. Yeah, so all you need is really just like a piece of paper and something to write with, and somebody who's willing to share their stories or their insights. And then we speak to scale map and image markup, which is another accessible and fairly straightforward method of mapping. And so what this is really just you blow up an image or a map, you print that off, and then you gather community around this image to discuss like what they see, and to tell stories around those features on the land, so they can draw or label directly onto this printed image. And yeah, we did see that in community is a really great community engagement tool, where people really got excited to share stories. And, you know, we had elders and youth sharing stories of just exchanging knowledge and understanding of those important spaces that were identified through looking at the map, right? And significant spaces are different in each community. So we did this in my community, and I learned about you know, old paths and trails that were used back in the day to sneak into town and stuff like that. It was really cool. The next mapping method to discuss is multimedia and internet-based mapping. So we included this kind of as like that in between. It's, you know, fairly intuitive. It's pretty accessible. It's a really great way to like create story maps on like Google Earth, and to tell stories of, you know, past, present, and future. It's just kind of that in between of, you know, pen and paper and then GIS. And so I wanted to include that in there, and that was used throughout the program as well. And then of course we have geographic information systems, so GIS. And so obviously this method of mapping is more complicated and technical, but it's a good way to integrate that local knowledge with qualitative data. So, you have that data visualization, the overlay and impact analysis. We've also seen it as a community engagement and active participation in community engagement, which I will speak to coming up here. And so throughout the land relationship visioning process, mapping has been used in a variety of ways to help create that vision. So obviously there's the documentation of those significant species and spaces. So we, go out, engage with community, and then put that onto a map, put that into a layer or whatever, and then that is then documented to visually articulate that knowledge. Like I've said, we've seen it used in community engagement. So communicate using maps to identify community needs and priorities. Mapping also, obviously, it does build capacity within community. So the use of maps to enhance informed decision-making within community and also to external agencies. When you know what you have and you know what is there, you can better communicate those needs and make those informed decisions for change or to address land use conflicts and things like that. And then another key aspect of mapping in land relationship visioning, and I think just across the board throughout First Nation communities or Indigenous communities across Canada would be that aspect of data sovereignty. So protecting and having ownership and control of sensitive information and understanding those boundaries, I guess, of what to share where and to who, and how to keep other things protected and private, and yeah. So now we'll get into some fun stuff. We, in collaboration with the Ontario Aboriginal Lands Association, we actually facilitated a 2-year program with a bunch of First Nation communities. I think we had 7 First Nation communities across Ontario, north, south, east, west, all over the place. And we provided funding to those communities to actually go through a 2-year process of facilitating and initiating land relationship visioning in community. And the way that I saw GIS being used in community was really, really interesting. It was a really great tool for active community participation. So GIS was used as a community engagement tool, and specifically Survey 123 was used as a tool. And Survey 123 is a tool through ArcGIS that allows you to create your own forms and surveys, I guess. And then you can, like you can see on the screen here, there's like a barcode, and those who want to participate can scan the barcode, and that form automatically comes up on your phone, and you can input your observations. And so for one community, a few different communities did this actually. And what they did was they created a form to document turtles when it was an active season for turtles. And, obviously there was prizes involved, and it was also just fun to be able to identify turtles. And when you actually use Survey 123, it like geo-references your location to where you are at that time. And it essentially puts all of that data together for you. And yeah, so when people actually submit information into the form, it pops up, and there you have, those hot spots where species are found. And, you can include any sort of questions that you want to include, like the species of the turtle, the location, or the way it was facing, what it was doing, if it was, walking across the road, if it was basking on a log, if it was nesting or whatever. And you can do this for anything. We saw this being used with bio blitzes as well. or other types of citizen science in community. So one way that communities went about identifying those significant species and spaces was to engage community in a community-wide bioblitz or a backyard bioblitz for those who, you know, didn't have the time to actually come out to a event. And so these forms were created using Survey 123, and those observations were documented automatically to using GIS straight to a map, and it's active participation, right? It gets community excited. It gets them actually involved in the acquiring data. And it also kind of like gets them thinking and observing things, taking note of things that you might observe all the time, but kind of bypass. And so this was a really great engagement tool. And it was proven to be like really successful with like over 50 participants in some cases and over 270 observations reported with, you know, 11 different reptile species and things like that. And so the only setback with this is you need cell service, you need internet connection to utilize this tool. So some communities did have difficulty using this tool as, you know, service can be unreliable. That being said, you can take pictures and then upload afterwards to Survey 123. And I guess it is worth noting in the update and relaunch of the LRV toolkit, we are exploring offline options to make sure that those that can be accounted for in the later version. And so we also saw GIS being used as a tool for community engagement follow-up. So essentially using it to report back to the community. What you see here is an image that was what was presented back to the community after one of those turtle observation contests using Survey 123. And so this shows right on the map where everything came up. It can show how many species, what kinds of species, where they were found. And this was actually presented back to the community as a way to visually communicate around what they have identified, the event that they've taken part in, the engagement that they've taken part in. And this really, you know, builded trust and community buy-in when there was this follow-up piece after engagement. It shows where that information provided is going, what it's being used for, and how it visually looks put together on a map. And so, yeah, we've seen story mapping after a BioBlitz, where significant species and spaces has been identified, and then conversations, community conversations around these maps and these images. And then we've also seen GIS used to digitize old traditional land use maps and create layers to the changes over time and and also to identify significant spaces and species based off of kind of, I guess, their category, whether it was like, you know, cultural or traditional species, you know, edible or medicinal species, or something that's harvested, something that's hunted, et cetera, et cetera. So kind of used layers to separate that information and create like a really informed map. So we've seen this used for scale up and image markup engagements. So, so I'm speaking about those accessible mapping methods that are, you know, pen to paper, and then actually taking those physical maps that were either drawn or marked up, and then matching those to, well, digitizing them. So creating a digital map and then creating layers from that. Creating layers from old maps was really interesting. So essentially, like, what some communities did is they found really old traditional land use maps. A lot of the times there's initiatives that happen in different departments, especially around traditional knowledge and traditional land use. And that's usually, these things are documented somewhere, but then they're kind of forgotten about. And so one community participant found an old map that she then like retraced everything, and then she digitized that. And then she held an engagement with elders and those knowledge holders to update the map to reflect the current traditional use. And they created layers to show the then versus now, which showed the traditional use areas had dwindled substantially. And yeah, so those changes over time were documented and shown using GIS. And yeah, like the way that I saw these significant spaces being identified was really, really interesting. It really took everything a lot further than what we normally kind of see in traditional use mapping or species at risk mapping and things like that. I saw communities create layers that showed those birthplaces of elders and old homesteads, recreational places, as well as like current and past gathering spaces tied to community stories. So it's all very community specific, and it was just really interesting to see the way that this was used in community. And so this is kind of the end of our presentation. I want to review some of the key takeaways here. So as we discussed, GIS can be used in a variety of ways to manage lands and resources within community and territory. It can also be a powerful tool to determine what is most important to community. It can be used to increase capacity, communicating land-based knowledge to assert rights and make informed decisions. And it can also be used as a tool to actively engage community in lands initiatives, which I really like. And so I guess if you would like support in GIS moving forward, I know you guys have a great program going into tomorrow, but you can also watch out for the relaunch of the LRV toolkit. I am working with the University of Toronto to take a deep dive into different GIS applications, such as QGIS and ArcGIS. And it's available online at our website, or it's also available on the Ontario Aboriginal Lands Association website. If your community is a member of OLA, you can also reach out to Clint King, who's the GIS technician, and he is working hard to support member communities in GIS application. I know he has done things like help map out invasive species for communities and has really helped to support member communities in using GIS in community. So yeah, if there's any questions, now's the time. Thanks.